By December 1941, the Nakajima B-5N Type 97 torpedo bomber was already obsolete. Its design dated to 1935. It had no armor. It carried a single defensive machine gun. Yet this antiquated aircraft sank more Allied warships than any other weapon in the Pacific War. Before we go deeper into how this decision changed the Pacific War forever, make sure to subscribe for more history that actually happened. The contradiction sits at the heart of one of aviation's strangest paradoxes. On December 7, 1941, the Kate, as Allied intelligence would name it, represented the cutting edge of naval aviation technology. Its crews attacked Pearl Harbor with a precision that stunned the world, sinking 5 battleships in a single morning. Yet the same aircraft, designed 6 years earlier, would continue flying combat missions until the final months of the war, long after every expert declared it hopelessly outdated. The answer lies not in the aircraft itself, but in the weapon it carried, the doctrine that guided it, and the men who flew it into the teeth of anti-aircraft fire at 60 feet above the waves. Understanding the Kate story requires understanding the Japanese Navy's philosophy in the 1930s. Japan had emerged from World War I as a recognized naval power, having fought alongside Britain and seized German Pacific possessions. The Washington Naval Treaty of 1922 limited Japanese capital ship tonnage to 60% of American or British levels. This ratio, designated 10-10-6 for Britain, America, and Japan respectively, rankled Japanese naval officers who saw it as proof of Western contempt. Unable to match American shipbuilding capacity ton for ton, Japanese planners sought asymmetric advantages. If they couldn't build more ships, they would build better ships. If they couldn't train more pilots, they would train superior pilots. If they couldn't manufacture more aircraft, they would manufacture aircraft optimized for decisive battle. This philosophy shaped every aspect of Japanese naval aviation development. The Navy envisioned future war as a series of carefully planned operations culminating in a decisive fleet engagement somewhere in the Western Pacific. American ships, sailing across vast ocean distances to relieve the Philippines or challenge Japanese positions, would be intercepted by the combined fleet in an encounter battle that would settle the war's outcome in a single afternoon. The aircraft carriers, once considered scouts and auxiliary vessels, increasingly appeared as potential war winners in such a scenario. Massed carrier strikes could cripple an enemy fleet before surface ships exchanged fire. The advantage would be decisive. This vision demanded specialized aircraft. Fighters to gain air superiority. Dive bombers to damage enemy carriers and suppress anti-aircraft fire. Torpedo bombers to sink capital ships below the waterline where armor was weakest. Each type needed to excel at its specific mission. Multi-role capability was dismissed as compromise that weakened specialized effectiveness. The torpedo bomber particularly required optimization because its mission, approaching within 500 meters of heavily defended targets, flying straight and level at wavetop height, demanded aircraft capable of surviving long enough to release weapons. The year 1935 marked a turning point in Japanese naval aviation. The Imperial Japanese Navy issued Specification 10-SHA, calling for a replacement to the Yokosuka B-4Y biplane torpedo bomber. The Navy demanded capabilities that seemed almost contradictory: long range for open ocean operations, high speed to survive fighter interception, heavy payload capacity for torpedoes or bombs, and the ability to operate from carrier decks with their severe space limitations. Most critically, the aircraft had to integrate seamlessly with the Navy's evolving doctrine of coordinated carrier strikes, a revolutionary concept that required perfect synchronization between torpedo bombers, dive bombers, and fighters attacking a single target simultaneously from multiple vectors. The 10-SHA specification landed on Nakajima's design desks in mid-1935. The requirements read like a wish list of contradictory capabilities. Maximum speed over 200 knots, fast enough to evade fighter interception. Range exceeding 1,000 nautical miles, sufficient for open ocean operations. Payload capacity for one 800-kilogram torpedo or equivalent bombs. Crew of 3 to handle piloting, navigation, and gunnery. Ability to fold for carrier storage while maintaining structural integrity for catapult launches and arrested landings. All this in an airframe light enough for single-engine operation. Katsuji Nakamura led the Nakajima design team that responded to this challenge. His approach rejected the biplane configuration still common in torpedo aviation worldwide. Instead, Nakamura conceived an all-metal, low-wing monoplane with stressed skin construction, techniques borrowed from American designs but refined for Japanese requirements. The prototype, internally designated Type K by Nakajima, incorporated hydraulically retractable landing gear, a first for Japanese single-engine naval aircraft. The wide stance gear attached directly to the main wing spar, providing stability during carrier landings while folding inward to minimize drag during flight. The wings themselves represented engineering compromise elevated to art form. Large enough to generate lift for heavy ordnance loads, they folded upward for carrier storage, with the right wing partially tucking under the left to achieve minimal stowed dimensions. The fuselage used semi-monocoque construction, where internal ribs strengthened an oval section skin, lighter than tubular frames yet strong enough to withstand carrier catapult launches and arrested landings. Nakamura's team adopted a Naka cowling design for the radial engine, minimizing aerodynamic drag while providing adequate cooling. Flush riveting covered every external surface. These details, dismissed by some as minor refinements, accumulated into a platform 30 miles per hour faster than its American counterpart, the Douglas TBD Devastator, and with range exceeding 1,000 miles with external tanks. Nakamura's design process drew from multiple sources. Nakajima had examined American aircraft, particularly designs from Northrop, Douglas, and Curtiss, looking for technological approaches applicable to Japanese requirements. The low-wing monoplane configuration came from studying these foreign aircraft, as did the hydraulic retractable landing gear. But Nakamura's team didn't simply copy American designs. They adapted principles to suit Japanese operational needs. American torpedo bombers like the TBD Devastator emphasized protection and crew comfort for pilots who might spend hours flying patrol missions. Japanese doctrine required speed and range for strike missions that would last hours but involve only minutes of actual combat. Protection, in this calculus, mattered less than performance. The wing design exemplified these trade-offs. Nakamura needed sufficient area for lift capacity while minimizing weight and drag. He settled on a wing with 37.7 square meters of area, large for a single-engine aircraft, using an NN-5 modified airfoil that provided good lift characteristics at slow speeds needed for carrier landings while maintaining reasonable drag at higher cruise speeds. The wing incorporated two main spars running spanwise, creating structural boxes between them where fuel tanks could be installed safely away from the hot engine yet close to the aircraft's center of gravity. This placement kept the fuel load from dramatically shifting the center of gravity as fuel burned off during long missions. The landing gear presented particularly difficult challenges. Carrier operations demanded robust gear capable of withstanding repeated catapult launches and arrested landings, forces that could reach 6 times the aircraft's weight. Yet the gear had to retract completely to minimize drag during flight. Nakamura's solution attached wide stance gear directly to the main wing spar, retracting inward into wells covered by hydraulically operated doors. This added weight and complexity but provided the strength needed for carrier operations while delivering the clean lines desired for high-speed flight. The hydraulic system, powered by an engine-driven pump, represented cutting-edge technology for Japanese naval aviation. It was the first such system installed on a single-engine Japanese carrier aircraft, and initial testing revealed numerous problems with fluid leaks and system failures. Nakajima engineers spent months debugging the hydraulics before achieving reliability. The fuselage cross-section was carefully shaped to accommodate the crew's needs while minimizing drag. An oval section, wider than it was tall, provided adequate interior volume for 3 men seated in tandem while presenting minimal frontal area to the airstream. Semi-monocoque construction used aluminum ribs and formers supporting a stressed aluminum skin, all joined by flush riveting that left the exterior smooth. This construction method, lighter than traditional tubular frames with fabric covering, also provided better resistance to battle damage. A bullet hole in stressed skin was less likely to cause catastrophic failure than damage to a load-bearing frame member. The engine installation required equal care. Nakamura initially planned around the Nakajima Hikari 2, a 9-cylinder radial producing 700 horsepower. The Naka cowling design, developed by American researchers to reduce drag around radial engines, was adapted for the Hikari installation. This cowling channeled cooling air smoothly around the cylinder heads while minimizing turbulence and drag. The three-blade propeller, initially fixed pitch in early prototypes, was upgraded to variable pitch and finally to constant speed in production models, allowing the engine to operate at optimal RPM across different flight conditions. The first prototype flew in January 1937. By late that year, the aircraft entered production as the Navy Type 97 carrier attack bomber, known as Sank for short. The designation reflected the Japanese calendar year 2597, which corresponded to 1937 in the Western calendar. Initial production models, designated B5N1, mounted a Nakajima Hikari 3 9-cylinder radial engine producing 840 horsepower at 3,000 meters altitude. This powerplant pushed the aircraft to a maximum speed of 229 miles per hour at 6,500 feet, respectable for a torpedo bomber but insufficient for the Navy's ambitions. What made the Type 97 revolutionary was not any single feature but rather its integration of crew, aircraft, and weapon into a unified system. The three-man crew sat in tandem under a single glazed canopy. The pilot occupied the forward position, his seat mounted on a pole that could raise or lower. During takeoff and landing, he elevated the seat to see over the aircraft's long nose, essential for a taildragger configuration. Once airborne, he lowered the seat to its cruising position, reducing wind resistance and fatigue on long-range missions. Behind the pilot sat the observer, navigator, and bombardier, three roles combined into one position. This crew member controlled the Type 90 bomb sight, a vertical tube mounted in the front left of his station, used for both level bombing and torpedo attack computations. A Type 3 reflector compass mounted on the cockpit frame enabled precise navigation across featureless ocean. During attack runs, the observer called corrections to the pilot through unpowered speaking tubes, brass communication systems known as Gosport tubes. No electrical intercoms complicated the system or added weight. The third crew position belonged to the radio operator and gunner. He operated one of two standard naval radio sets, the Type 96 Mk3 in early models, later replaced by the Type 2 Mk3. His defensive armament consisted of a single 7.7mm Type 92 machine gun mounted on a flexible ring at the rear of the cockpit. The gun used drum magazines holding 97 rounds each, hand-loaded by the gunner. This represented the aircraft's only defensive capability. No armor protected the crew. No self-sealing tanks guarded the fuel. The Navy's calculation was simple: armor and protection added weight, weight reduced speed and range. And speed and range offered better protection than steel plate. Events would prove this logic both brilliantly effective and tragically flawed. The Type 97's offensive capability centered on its external ordnance racks. Different racks accommodated different weapons, but changing configurations required more than 2 hours of ground crew work. The most common loadout carried a single Type 91 torpedo, a weapon specifically designed for aerial delivery. Alternatively, the aircraft could mount one 800-kilogram bomb, three 250-kilogram bombs, or 6 60-kilogram bombs. The variety allowed tactical flexibility but created logistical complications during combat operations, particularly when commanders needed to switch between torpedo and bombing configurations under battle conditions. By 1938, the Type 97 saw its first combat action in China during the Second Sino-Japanese War. Operating from carriers and land bases, B5N1S struck Chinese targets with level bombing attacks. The combat experience revealed critical weaknesses. The lack of armor and self-sealing fuel tanks made the aircraft vulnerable even to light ground fire. Crews returned with bullet holes punched through fuel tanks, wings, and fuselage. Several aircraft failed to return at all. The Navy studied these losses carefully. Their conclusion surprised Western observers: rather than add armor, they would increase speed to outrun defensive fire. This decision led to the B5N2, the definitive production variant. Nakajima replaced the Hikari engine with their new Seiki 11, a 14-cylinder twin-row radial producing 1,000 horsepower at takeoff and 970 horsepower at 3,000 meters. This same engine would power the early models of the Mitsubishi A6M0 fighter. Additional streamlining modifications reduced drag. The result delivered only marginal speed improvement. Maximum velocity increased from 229 to 235 miles per hour, but the more powerful engine improved takeoff performance with heavy loads and provided better climb rates. The B5N2 entered production in 1939, replacing the B5N1 on carrier decks. By December 1941, it equipped all 6 carriers of the Kido Butai, the Japanese carrier striking force. The aircraft specifications tell only part of the story. What made the Type 97 lethal was not its airframe but the sophisticated tactical system built around it. Japanese naval aviation spent years developing coordinated attack doctrines. Unlike American carrier air groups, which launched strikes piecemeal as aircraft became ready, Japanese carriers synchronized their launches into massive, integrated strike packages. Multiple carriers would launch simultaneously, forming up their aircraft into precise formations before proceeding to the target as a single coordinated wave. This doctrine demanded extensive training. Japanese naval aviators underwent the most rigorous selection and training program in the world. Pilot candidates began training at age 16 or 17, spending years mastering their craft before reaching operational squadrons. By 1941, the average Japanese carrier pilot had logged over 800 hours of flight time, with veteran pilots exceeding 2,000 hours. American pilots in the same period typically had 300 hours. This experience gap translated directly into combat effectiveness. Torpedo attack training pushed crews to their limits. Pilots learned to approach targets at wavetop height, maintaining precisely 100 meters altitude while flying at exactly 160 knots indicated airspeed. At 500 meters from the target, the observer would call for release. The pilot would press the torpedo release button while maintaining absolutely level flight, no pitch, no yaw, no roll. Any deviation would throw the torpedo off course. After release, the pilot would bank hard, usually to the left, while shoving the throttle forward to maximum power. The aircraft would skim across the wave tops, weaving to avoid defensive fire, while the torpedo streaked toward the target ship. The torpedo itself represented years of refinement. The Type 91 Modification II aerial torpedo measured 5.275 meters long and weighed 835 kilograms. Its warhead carried 205 kilograms of Type 97 explosive, a picric acid-based compound more powerful than TNT. The torpedo could run 2,000 meters at 42 knots. What made it revolutionary was its ability to be dropped from aircraft flying at speeds up to 160 knots and at altitudes up to 100 meters, conditions that would destroy American or British torpedoes of the period. Developing the Type 91 torpedo proved as challenging as designing the aircraft to carry it. Aerial torpedoes faced problems unknown to ship-launched torpedoes. The weapon had to survive being dropped from an aircraft flying at 160 knots and 100 meters altitude, an impact that generated enormous forces. It had to enter the water cleanly despite having no control during its fall. It had to stabilize quickly after water entry and begin running on the correct heading toward the target. Early aerial torpedoes from all nations failed these requirements regularly. British torpedoes at Taranto in 1940 achieved only about 30% hits despite ideal conditions. American Mark 13 torpedoes proved so unreliable that aviators initially refused to carry them. Japanese engineers approached the problem systematically. They recognized that the torpedo's freefall through air created the primary difficulty. Without control during descent, the weapon could tumble, strike the water at odd angles, or break apart from impact forces. The solution involved adding temporary stabilizing fins that would guide the torpedo during its fall and then break away upon water entry. Wooden fins attached to the tail section acted as simple aerodynamic surfaces, keeping the weapon oriented nose down during descent. Upon striking water, the wooden fins would shatter from impact forces or break away at pre-weakened attachment points. The Type 91 sophistication lay in its fins. Wooden stabilizing fins attached to the tail prevented the torpedo from tumbling during its fall from the aircraft. These fins broke away upon water entry, designed to separate at precisely the right moment. More ingeniously, anti-roll fins mounted on the torpedo's rear horizontal rudders corrected for any rolling motion. During water entry, if the torpedo entered the water at an angle, these fins would automatically adjust to bring it upright before beginning its underwater run. This innovation allowed Japanese torpedo bombers to attack in rougher seas and shallower harbors than Allied aircraft could manage. The 6 months between the B-5N2's operational debut in 1940 and the Pearl Harbor attack in December 1941 saw intensive training that transformed good crews into exceptional ones. Japanese carrier air groups drilled endlessly on coordinated attacks. Fighters, dive bombers, and torpedo bombers would launch separately, form up into massive strike packages, and approach targets in carefully choreographed sequences. The torpedo bombers, being slowest, would launch first. They would fly toward the target at cruise speed, conserving fuel. The faster dive bombers would launch second, catching up with the torpedo bombers en route. The fighters, fastest of all, would launch last and overtake both bomber groups to arrive first at the target area, sweeping enemy fighters from the sky before the vulnerable bombers arrived. This coordination demanded precise navigation. In the featureless Pacific, with no landmarks and only sun, stars, and compass for reference, navigators needed to guide their aircraft to targets hundreds of miles away, arriving within minutes of other groups launching from different carriers. They practiced with training torpedoes, weighted to fall like real weapons but containing no explosives. Pilots would approach target ships at precisely the right altitude and speed, release practice torpedoes, and observe where they ran. Errors were analyzed. Too high and the torpedo would hit the water at the wrong angle. Too fast and it might break apart. Too slow and the approach gave defenses too much time to engage. Every training mission revealed deficiencies that required correction. By December 1941, the 6 carriers of the Kido Butai operated as a single integrated unit. Their combined air groups had trained together for months. Pilots knew not just their own aircraft but the capabilities and limitations of every other aircraft in the strike package. They understood timing, how long each phase of the attack would take, when they needed to arrive, how much fuel remained for the return flight. They had practiced attacks against moving targets that employed evasive maneuvers and simulated defensive fire. Nothing in their training, however, prepared them for the unique conditions at Pearl Harbor. Pearl Harbor demonstrated the Type 97's capabilities at their devastating peak. On the morning of December 7, 1941, 144 Kates participated in the two-wave attack. 40 B-5N2s from the carriers Akagi, Kaga, Hiryu, and Soryu carried torpedoes in the first wave. Each torpedo had been modified specifically for Pearl Harbor's shallow 40-foot depths. Engineers added additional wooden fins and adjusted the torpedo's diving angle to prevent it from plunging too deep and striking the harbor bottom. This modification, accomplished in just weeks before the attack, represented Japanese attention to technical detail. The first wave's torpedo attack began at approximately 7:57 a.m. 24 Kates approached from the east, emerging from the southeast lock in a long line, each aircraft several hundred meters behind the previous one. This spacing gave individual pilots brief moments to select targets without interference from preceding aircraft's wakes or explosions. The attacking aircraft flew at 60 to 80 feet above the water, engines at full power, pilots concentrating absolutely on maintaining level flight. Observers called ranges through the speaking tubes. At 500 meters, pilots pressed release buttons. Type 91 torpedoes dropped away, their wooden fins preventing tumbles, then splashed into the harbor. The fins broke away. The torpedoes straightened, accelerated to 42 knots, and ran toward Battleship Row. The Type 91 torpedoes carried that morning had been specially modified. Standard torpedoes dropped from 100 meters would plunge 20 to 30 meters before stabilizing, far too deep for Pearl Harbor's 12-meter depths. Engineers added additional wooden stabilizing fins and adjusted the torpedo's horizontal rudders to minimize plunge depth. Test drops at Kagoshima Bay, where water depths approximated Pearl Harbor's, refined the modifications until torpedoes consistently ran at depths under 10 meters. This attention to detail, completed just weeks before the attack, exemplified Japanese operational planning. The battleships Oklahoma and West Virginia sat directly in the line of approach. Oklahoma took 3 torpedoes in rapid succession, massive explosions tearing through her port side. She began listing immediately. West Virginia absorbed 7 torpedo hits, more than any other ship that morning. Her magazines flooded deliberately by damage control parties who opened seacocks to counter-flood and prevent capsizing. California took 2 torpedo hits that flooded her engine rooms and magazines. She settled slowly to the harbor bottom over the next 3 days. Only the inner battleships, Tennessee, Maryland, and Arizona, remained safe from torpedoes, protected by their outboard neighbors. 49 Kates in the first wave carried bombs instead of torpedoes. These aircraft climbed to 10,000 feet and approached from the south in precise 5-plane chevrons called Chutai formations. Each aircraft carried a single Type 99 No. 80 Mark V special bomb, an 800-kilogram weapon converted from 16-inch naval artillery shells. These bombs were essentially solid steel projectiles with small 22-kilogram explosive charges, designed to pierce armored decks through mass and velocity rather than explosive force. At 10,000 feet, bombardiers sighted through their Type 90 bomb sights while pilots maintained formation. On the lead aircraft signal, all 5 aircraft in each formation released simultaneously, creating a pattern of bombs that carpeted the target area. Accuracy suffered at such altitude. Only 8 bombs struck battleships, but 1 achieved devastating effect. A single 800-kilogram bomb crashed through Arizona's deck and detonated in her forward powder magazine. Over 1,000 pounds of powder exploded in a fireball that lifted the battleship's bow, broke her keel, and killed 1,177 men in seconds. The second wave brought more Kates, 54 aircraft armed with bombs to strike airfields and port facilities. These aircraft carried mixed loadouts, some with 2 250-kilogram bombs, others with 1 250-kilogram bomb and 6 60-kilogram bombs. They attacked Kaneohe Naval Air Station, Hickam Field, and other military installations across Oahu, systematically destroying aircraft on the ground and damaging infrastructure. By 9:45 a.m., the attack ended. Only 5 Kates had been shot down from the 144 that participated, a loss rate of 3.5%. The devastation they achieved redefined naval warfare. 5 battleships sunk, 3 damaged. The Pacific Fleet's battle line effectively eliminated. Japan's carrier striking force escaped without losses. The Type 97 had performed flawlessly. Yet even as the Kido Butai sailed home to triumphant welcomes, the aircraft's obsolescence clock was already ticking. Yet even at Pearl Harbor, signs of vulnerability appeared. 5 Kates failed to return from the 144 that attacked. Lieutenant Commander Shigekazu Shimazaki led the second wave, arriving over Oahu after the initial surprise had evaporated. American anti-aircraft gunners, shocked into action by the first wave, now fired with desperate intensity. Every ship that could bring guns to bear did so. Every anti-aircraft battery ashore joined the barrage. The sky filled with exploding shells. Shimazaki's Kates, attacking airfields and port facilities with bombs, flew through this steel curtain. 1 Kate took a direct hit from a 5-inch shell and disintegrated. Another, its fuel tank ruptured by machine gun fire, trailed flame before crashing into the hills north of Pearl Harbor. 3 more fell to concentrated defensive fire. The 3.5% loss rate seemed acceptable by military standards, but it foreshadowed the future. When defenders could react, when surprise was lost, Kates died. The fundamental problem was protection. The Navy's pre-war decision to prioritize speed over armor made sense when facing Chinese anti-aircraft defenses and early-model fighter aircraft. But American F-4F Wildcat fighters, though slower than Japanese Zeros, carried 6.50 caliber machine guns firing armor-piercing incendiary rounds. A single burst from a Wildcat could shred a Kate's unprotected fuel tanks, set the aircraft ablaze, or kill crew members instantly. American carrier doctrine emphasized fighter protection, with combat air patrols orbiting at altitude ready to dive on attacking aircraft. Against such defenses, the Kate's lack of protection became a death sentence. The crew aboard each Kate understood their vulnerability with visceral clarity. Juzo Mori, who attacked California at Pearl Harbor, later described the experience of flying a torpedo run. The approach began miles out, skimming wavetops at 60 feet altitude. At this height, every detail of the ocean's surface became visible: individual whitecaps, floating debris, the wakes of ships ahead. The pilot's entire existence compressed to 16 instruments, the voice of the observer calling ranges through the speaking tube, and the throttle position that balanced speed against fuel consumption. Any throttle adjustment caused fuel burn to spike in a heavily loaded aircraft. Pilots learned to fly smoothly, making minimal corrections, preserving every gallon for the return flight. As the target grew larger, anti-aircraft fire began. First came the heavy shells, 5-inch from destroyers and larger ships, 3-inch from shore batteries. These exploded at altitude, black puffs that initially seemed to pose little threat to aircraft flying at 60 feet. But tracers followed. Smaller caliber weapons, 40mm, 20mm, .50 caliber machine guns, reached out toward the attacking aircraft. At 500 meters from target, with tracers streaming past the cockpit and shell splashes erupting in the water below, the observer called for release. The pilot pressed the button. The torpedo dropped. The aircraft, suddenly 835 kilograms lighter, leaped upward. The pilot banked hard left, the standard doctrine, while advancing the throttle to maximum power. The Kate accelerated slowly, painfully, while shells and bullets sought it. Pilots jinked left and right, making themselves difficult targets, while fighting to maintain altitude and speed. Some made it. Some didn't. The difference often came down to seconds or meters, whether a particular burst of machine gun fire struck fuel tank or empty space. The aircraft's speed disadvantage magnified the problem. At 235 miles per hour maximum, the B-5N2 was slower than every American fighter in service. The Wildcat cruised at 260 miles per hour and could reach 330 miles per hour in a dive. The Type 97 couldn't run, couldn't hide, and couldn't fight. Its only defense was its mission: get the torpedo off before the fighters arrived. This vulnerability showed starkly at the Battle of the Coral Sea in May 1942. Japanese carriers Shokaku and Zuikaku launched strikes against the American carrier Lexington. 12 Kates carrying torpedoes approached at wavetop height while dive bombers attacked from above. American fighters intercepted before the torpedo bombers reached release range. Wildcats dove on the formation, .50 caliber guns hammering. Kates burned and fell. Of the 12 torpedo bombers, 5 were shot down before releasing their weapons. The 7 survivors pressed their attacks, dropped torpedoes, and escaped through intense anti-aircraft fire. 2 torpedoes struck Lexington, contributing to her eventual loss, but the 42% loss rate among the torpedo bombers shocked Japanese commanders. Between Pearl Harbor and Midway lay 6 months of combat that revealed both the Kate's effectiveness and its mounting costs. In April 1942, Kates from carriers Shokaku, Zuikaku, Akagi, Kaga, and Hiryu attacked British shipping in the Indian Ocean. Operating against opponents with limited fighter protection and obsolete anti-aircraft systems, the Kates achieved the same devastating results as at Pearl Harbor. They sank the carrier Hermes, the cruisers Cornwall and Dorsetshire, and multiple merchant vessels. Loss rates remained minimal, under 5%. The aircraft performed exactly as designed when facing inferior opposition. The Battle of the Coral Sea in May changed the equation. For the first time, Japanese carrier aircraft faced American carrier aircraft under relatively equal conditions. When Shokaku and Zuikaku launched strikes against Lexington and Yorktown, American F-4F Wildcats rose to intercept. The Wildcats, though slower than Zero fighters, proved devastatingly effective against Kates. Lieutenant Commander Kakuichi Tokahoshi led the torpedo attack against Lexington, 12 Kates approaching from multiple vectors while dive bombers struck from above. American fighters dove on the torpedo bombers while they were still 5 miles from their target, formations string out in standard approach patterns. The Wildcats selected individual Kates and closed to point-blank range. Their 6.50 caliber machine guns, firing armor-piercing incendiary ammunition, could saw a Kate in half with a 2-second burst. 5 Kates burned and fell before reaching release range. The remaining 7 pressed through, weaving desperately while maintaining enough stability to aim their torpedoes. 2 torpedoes struck Lexington's port side. The massive carrier shuddered from the impacts but continued operating her aircraft. The torpedo hits contributed to Lexington's eventual loss, though internal explosions from aviation fuel vapors proved the final cause, but the cost ratio troubled Japanese commanders. 5 aircraft lost from 12 cent meant a 42% loss rate. Such attrition couldn't be sustained. Shokaku suffered similar losses when Lexington and Yorktown struck back. American dive bombers and torpedo planes attacked the Japanese carrier while her own strike was still airborne. 3 bombs struck Shokaku's flight deck, starting fires and preventing aircraft recovery. The Kate crews returning from their attack on Lexington found their carrier unable to land them. Some diverted to Zuikaku. Others, low on fuel, ditched in the ocean. Destroyers recovered some crews. Most drowned. The battle ended with both sides withdrawing, neither having achieved decisive victory. But the exchange rate worried Japanese planners. They had lost experienced crews, men with years of training and multiple combat missions, for results that didn't justify the cost. Midway in June 1942 demonstrated the terrible mathematics of unescorted torpedo attacks. The Kido Butai launched strikes against American carriers Yorktown and Enterprise. 40 Kates formed the torpedo attack wave. American fighters intercepted while the torpedo bombers were still miles from their targets, flying straight and level at wave-top height, perfect targets. The Wildcats dove in groups, selecting individual Kates and shooting them down methodically. Burning aircraft tumbled into the Pacific. Some Kates tried to jettison their torpedoes to gain speed and maneuverability. It made no difference. By the time the survivors reached release range, more than half had been shot down. The remaining Kates dropped their torpedoes in desperation and scattered. Their torpedoes ran true, several narrowly missed Yorktown, but most passed harmlessly. Only 6 of 40 torpedo bombers returned to their carriers. Yet the Type 97 remained in production. Why? The answer reveals much about Japanese wartime industry and the compromises forced by technological lag. Nakajima had developed a replacement, the B-6N Tenzan, designated JIL by Allied intelligence. Larger, faster, and better armed, the B-6N promised everything the B-5N lacked. But the new aircraft suffered from persistent engine problems. Its Nakajima Mamoru radial engine proved unreliable, prone to overheating and mechanical failures. Production delays mounted. The Navy faced a choice: continue building the obsolete but reliable B-5N, or wait for the superior but troubled B-6N. They chose both. B-5N production continued through 1943 while engineers struggled to fix the B-6N. This decision meant that for 2 more years, Type 97s would fly combat missions with crews fully aware of their aircraft's limitations. The Kate served at Eastern Solomons in August 1942, where 27 torpedo bombers attacked the carrier Enterprise. American fighters shot down 12. At Santa Cruz in October 1942, 19 Kates launched torpedoes at Hornet and Enterprise. 8 were shot down, but their sacrifice achieved results. 4 torpedoes struck Hornet, crippling her so severely that she had to be abandoned and sank that evening. It was the last time the Type 97 would sink an American carrier. The Kate crews who survived Midway returned to carriers that would never again operate at full strength. Akagi, Kaga, Hiryu, and Sarayu, 4 of the 6 carriers that struck Pearl Harbor, lay at the bottom of the Pacific. Their air groups, including dozens of experienced Kate crews, died with them. Zuikaku and Shokaku survived, but crew losses forced reorganization. Replacement pilots arrived with abbreviated training, 600 hours instead of 800, then 400 hours, then 200. They flew the same aircraft but lacked the skill to employ it effectively. At the Battle of the Eastern Solomons in August 1942, Kate torpedo attacks against Enterprise achieved minimal results despite numerical superiority. The new crews couldn't coordinate their attacks properly. They approached from predictable vectors. They released torpedoes at excessive ranges. American fighters shot them down in droves. At Santa Cruz in October 1942, the Kate achieved its last great success. Lieutenant Commander Shigeru Murata led a perfectly executed torpedo attack against the carrier Hornet. 19 Kates approached from multiple vectors simultaneously while dive bombers struck from above. The coordination, reminiscent of Pearl Harbor, overwhelmed American defenses. 4 torpedoes struck Hornet's hull. The carrier lost power and began listing. Eventually abandoned, she was sunk by Japanese destroyers that evening. But 8 of 19 torpedo bombers were shot down, a 42% loss rate matching Coral Sea. Murata himself died in the attack. His replacement lacked comparable skill. The Kate's tactical edge was eroding along with the men who knew how to employ it properly. The Guadalcanal campaign from August 1942 through February 1943 ground down what remained of experienced Kate crews. Land-based Kates flying from Rabaul attacked American shipping supporting the Marines ashore. The distances, over 600 miles one way, pushed the Kate to its range limits. Crews flew 4-hour missions to reach targets, faced intense anti-aircraft fire and fighter interception, then flew 4 hours back to base. Many ran out of fuel on return flights and ditched at sea. Others, damaged by defensive fire, struggled back to Rabaul only to crash on landing. The attrition rate approached 20% per mission. Within months, experienced crews were gone. Their replacements lasted days or weeks before dying in turn. By 1943, the dynamic had shifted fundamentally. American fighters improved with the introduction of the F-6F Hellcat, which combined Wildcat ruggedness with 380 miles per hour speed. American carrier air groups grew larger, with more fighters screening each strike. Radar-directed fighter direction improved American combat air patrol efficiency. Most critically, American anti-aircraft systems proliferated. The proximity-fused 5-inch shell, entering service in 1943, could detonate near aircraft without direct hits. The 40mm Bofors quad mounts, installed on every American warship by mid-1943, created walls of exploding steel at precisely the altitudes where torpedo bombers had to fly. The 20mm Oerlikon cannon, mounted in dozens on large ships, added close-range defensive firepower. Attacking ships had become suicidal. Japanese doctrine adapted. Rather than replace the Type 97 immediately with the still problematic B-6N, the Navy shifted Kate operations to secondary roles. The aircraft began flying anti-submarine patrols, equipped with Type 3 Mark 6 model for radar. These early air-to-surface radars operated at 150 MHz, with effective ranges of 110 km against large ships and considerably less against submarines. Kates patrolled behind convoys, sweeping search patterns to detect submerged submarines before they could attack. The long-range capability that made the Kate an effective torpedo bomber translated perfectly to patrol work. Others flew training missions, converting veteran attack pilots into proficiency and preparing new crews for operational squadrons. The B-5N-1K designation applied to Kates modified specifically for training, with dual controls and modified interiors. Still others performed target towing duties, dragging sleeves behind them while fighter pilots practiced gunnery. These unglamorous roles preserved aircraft and crews for missions where obsolescence mattered less. Yet Kates continued flying combat missions. In October 1944, during the Philippines campaign, Navy commanders threw everything available against the American invasion fleet. Land-based Type 97s launched from Philippine airfields, attacking with torpedoes and bombs despite overwhelming American air superiority. Losses approached 80%. The few survivors limped back to bases that would be overrun within days. The sacrifice achieved negligible results. Training squadrons absorbed many surviving Kates. The Himeji, Omura, and USA Kokutais, training air groups, operated dozens of B-5N-1S and B-5N-2S, teaching new pilots the fundamentals of torpedo attack doctrine. Instructors, often veterans of Pearl Harbor or Coral Sea, taught students who would never match their skill. The training curriculum had been compressed from years to months, then months to weeks. Students learned to fly the Kate, learned basic navigation, learned how to drop a torpedo in calm conditions. They didn't learn the 1,000 small skills that separated survival from death in combat: how to read defensive fire patterns, how to coordinate with other aircraft, how to escape after release. There wasn't time. The anti-submarine patrols allowed Kate crews to contribute without facing overwhelming opposition. Equipped with Type 3 Mark 6 radar sets, Kates flew patrol patterns behind convoys, searching for submarines. The radar, primitive by Allied standards, could detect large ships at 110 kilometers and submarines at considerably shorter ranges. The patrols required endurance rather than combat skill. Crews flew 6, 8, sometimes 10-hour missions, scanning empty ocean while hoping not to encounter enemy fighters. Occasionally they detected submarines and attacked with depth charges. More often they found nothing and returned to base. It was unglamorous work, but it preserved crews and aircraft for a future that never came. The Marianas Campaign in June 1944, the Battle of the Philippine Sea, saw the last major carrier operation involving Kates. Japanese carriers launched strikes against the American invasion fleet off Saipan. Over 400 aircraft participated, including approximately 50 Kates. American fighter direction, guided by radar, intercepted the strikes while they were still miles from targets. The Hellcats, newer, faster, more heavily armed than Wildcats, methodically shot down Japanese aircraft. Fewer than 20 Kates survived to reach attack range. Their torpedoes, dropped hastily under intense pressure, all missed. American fighters pursued the survivors, shooting down most before they could return to their carriers. Of the 50 Kates launched, perhaps 10 returned. The air groups never recovered. This battle, called the Great Marianas Turkey Shoot by American pilots, effectively ended Japanese carrier aviation as a significant force. The final roll came in 1944 and 1945, kamikaze. The aircraft that once required years of training to fly effectively now became a weapon for pilots with mere weeks of instruction. Young men, some barely out of their teens, climbed into Kates loaded with bombs and flew one-way missions toward American ships. The calculations that once demanded precision, altitude, speed, release range, no longer mattered. Only one calculation remained: pointing the aircraft at a target and keeping it pointed until impact. The Type 97's robust construction, reliable engine, and stable flight characteristics made it suitable for this grim purpose. Dozens flew kamikaze missions, crashing into destroyers, transports, and escort carriers. They achieved a few successes, sinking or damaging several smaller vessels, but mostly they died in anti-aircraft fire or crashed short of their targets. By August 1945, when Emperor Hirohito's radio broadcast announced Japan's surrender, approximately 1,149 Type 97s had been built. Of these, none survived the war intact. Every operational Kate had been expended, shot down, crashed, destroyed in kamikaze attacks, or scrapped when peace came. Only fragments remained, a partial fuselage recovered from the Kuril Islands, now in a British museum. Another reconstruction at Pearl Harbor's Pacific Aviation Museum, assembled from parts and wreckage. These remnants represent all that physically survives of the aircraft that sank more Allied warships than any other Japanese weapon. The Type 97 story illuminates a paradox at the heart of the Pacific War. Japan entered the conflict with the world's best carrier-based torpedo bomber, flown by the world's best-trained naval aviators, executing the world's most sophisticated coordinated attack doctrine. They achieved stunning victories in the war's first year. Yet the very factors that enabled those victories, intensive training, coordinated tactics, precision weapon delivery, could not be sustained once the war shifted to attrition. America's industrial capacity produced more carriers, more aircraft, more trained pilots than Japan could match. By 1943, sheer numbers overwhelmed quality. The loss of experienced crews at battles like Midway, Eastern Solomons, and Santa Cruz could not be replaced. New pilots received abbreviated training, weeks instead of years. They flew the same obsolete aircraft into the same defensive meat grinders, achieving a fraction of the results at many times the cost. The Kate remained deadly not because it had improved, but because its fundamental mission, putting a torpedo into a ship's hull below the waterline, remained unchanged throughout the war. The physics of naval warfare cared nothing for armor, speed, or protection. A Type 91 torpedo delivered by a desperate pilot in 1945 would sink a ship just as thoroughly as one delivered by an expert in 1941. The difference lay in the probability of delivery. In 1941, with surprise and superior training, that probability approached certainty. By 1944, it had dropped to 1 chance in 5. By 1945, it barely reached 1 in 10. The equation no longer balanced. The aircraft's technical specifications tell the story of its obsolescence. Maximum speed, 235 miles per hour when American fighters flew 380. Service ceiling, 27,100 feet when combat occurred at 30,000. Defensive armament, 1 rifle caliber machine gun when attackers brought 8.50 caliber weapons. Range, 1,200 miles, still impressive, but meaningless if the aircraft couldn't survive to use it. Protection, none, against enemies with extensive armor and self-sealing tanks. On paper, the Type 97 belonged in a museum by 1943. Yet it continued flying because Japan had no alternative. The B-6N Tenzan never entirely replaced it. Production of the newer aircraft reached only 1,268 units, barely exceeding Kate production numbers. Engine problems persisted throughout the B-6N's service life. Many units preferred keeping their Kates, accepting obsolescence as the price of reliability. This technological stagnation reflected deeper Japanese industrial constraints. While American factories churned out thousands of TBF Avengers, modern torpedo bombers with 275 miles per hour speed, armor protection, and heavy defensive armament, Japanese industry struggled to produce sufficient aircraft of any type. The Navy needed fighters desperately. The Zero, despite its own obsolescence, received production priority over bombers. Torpedo bombers, once the elite of naval aviation, fell to secondary status in a war increasingly dominated by fighter-versus-fighter combat and kamikaze tactics. The strategic context matters for understanding the Kate's extended service. In 1935, when Katsuji Nakamura designed the aircraft, Japan envisioned a short war with decisive naval battles determining victory. The Kate embodied that vision, a specialized weapon for a specialized mission, optimized for the single coordinated strike that would cripple an enemy fleet. The reality was grinding attrition, where the enemy replaced losses faster than Japan could inflict them. In such a war, the Kate's specialization became a liability. It could do one thing superbly, deliver torpedoes, but that one thing became increasingly suicidal as American defenses improved. The aircraft couldn't be easily converted to other roles. It lacked the speed for reconnaissance, the armament for ground attack, the range for strategic bombing. It remained a torpedo bomber when torpedo bombing had become nearly impossible. Yet individual actions throughout the war showed what the Type 97 could achieve with proper conditions. At Pearl Harbor, near-perfect conditions produced devastating results. At Coral Sea, good conditions achieved significant success. At Midway, unfavorable conditions led to slaughter. The aircraft hadn't changed, conditions had. The Kate demanded specific circumstances to be effective: surprise or fighter protection, weak or distracted defenses, targets that couldn't maneuver violently. As the war progressed, those circumstances became vanishingly rare. American doctrine specifically evolved to deny them, emphasizing fighter protection, radar early warning, and massive defensive firepower. The mathematics of aerial warfare worked against Japan from the start. Each Kate lost at Pearl Harbor could be replaced. Japan had built 669 aircraft by the end of 1941 and production continued. Each pilot killed could theoretically be replaced through training programs. But the experience couldn't be replaced. The pilot who died at Midway after surviving Pearl Harbor and Coral Sea took years of accumulated knowledge with him. The replacement pilot might fly the same aircraft but lacked the 1,000 small lessons learned through combat experience. This erosion of expertise, slow at first but accelerating with each major battle, ultimately proved fatal to Japanese carrier aviation. The strategic miscalculation extended beyond individual battles. Japanese planners assumed the war would be short, 6 months to a year of intensive operations followed by negotiated settlement. The Type 97, optimized for this short war scenario, made perfect sense in that context. But America refused to negotiate after Pearl Harbor. The war stretched into years. Industrial production mattered more than individual platform quality. Training pipelines needed to produce hundreds of pilots annually, not dozens. Aircraft needed to be robust enough for green pilots to fly safely, not delicate thoroughbreds requiring expert handling. The Kate, and the entire Japanese naval aviation system built around it, couldn't adapt to this war of attrition. The crews who flew Kates into combat from 1941 to 1945 knew these truths intimately. The pilots who attacked Pearl Harbor went on to die at Midway, Guadalcanal, Santa Cruz. Those who survived those battles died at Philippine Sea or Leyte Gulf. The few who somehow survived the war's carrier battles found themselves flying anti-submarine patrols or kamikaze missions. Their expertise, earned through years of training and combat, ended up wasted in a war that valued quantity over quality. They flew obsolete aircraft on missions that had become obsolete, following tactical doctrines designed for a war that never materialized. The Type 97 story ends not with a final battle but with gradual dissolution. By August 1945, only handfuls remained operational, scattered across Pacific Islands and Japanese home islands. Surrender orders grounded them permanently. Occupation forces scrapped most as hazardous materials. A few became curiosities, examined by American intelligence officers studying the enemy's equipment. The reports show surprise that such a primitive aircraft had achieved so much. The lack of armor, the weak defensive armament, the modest performance, all seemed inadequate for the results claimed. Yet the claims were verified. Pearl Harbor wreckage told the story in twisted steel and oil-slicked water. The weapons that sank the Kates tell their own story. American anti-aircraft systems in 1941 consisted primarily of .50 caliber machine guns for close defense and 5-inch guns for long-range work. The 5-inch guns used time-fused shells that exploded at preset altitudes, often missing low-flying torpedo bombers entirely. The .50 caliber machine guns, while effective, had limited range. This gap in medium-range defensive capability, between 1,000 and 3,000 yards, gave torpedo bombers a window to approach, release, and escape. By 1943, that window had closed. American ships mounted 40mm Bofors guns in quad mounts, producing walls of explosive shells at precisely the altitudes where torpedo bombers flew. The Bofors had effective range to 4,000 yards and rate of fire sufficient to saturate approach paths. Closer in, 20mm Oerlikon cannons added another layer of defense, firing high-explosive shells that could down aircraft with single hits. Every American ship bristled with these weapons. Large carriers mounted over 100 anti-aircraft guns of various calibers. Even destroyers carried enough firepower to down multiple aircraft. The proximity fuse, introduced in 1943, revolutionized anti-aircraft effectiveness. Rather than requiring direct hits or precise altitude settings, proximity-fused 5-inch shells exploded automatically when passing near aircraft. A shell that passed within 70 feet of a Kate would detonate, sending shrapnel through its unarmored structure. The fuse turned misses into kills. Japanese pilots reported that American defensive fire seemed to have become impossibly accurate, shells exploding precisely where aircraft flew. The truth was more sophisticated, the shells didn't need accuracy anymore. Radar completed the defensive revolution. American ships mounted air search radars that detected incoming raids at ranges exceeding 100 miles. Fighter direction centers aboard carriers vectored Hellcats toward incoming strikes, positioning them for optimal interception. The Japanese coordination that had devastated Pearl Harbor now worked against them. Large formations showed clearly on radar screens. Fighter directors could see them coming, estimate their target, and position interceptors accordingly. What had been surprise in 1941 became anticipated in 1943. The Kates flew into prepared defenses that knew they were coming, knew their approach vector, and had fighters positioned to intercept. The technological comparison with American torpedo bombers illuminates different design philosophies. The Douglas TBD Devastator, the Kate's contemporary in 1941, emphasized protection over performance. It flew slower, 205 miles per hour maximum, but carried armor plate behind the pilot and self-sealing fuel tanks. In combat, neither attribute saved it. At Midway, Devastators suffered even worse than Kates, with 37 of 41 shot down in a single day. The Devastator's replacement, the Grumman TBF Avenger, represented a different generation entirely. Larger, heavier, and more powerful, the Avenger mounted a 1,900 horsepower engine that pushed it to 275 miles per hour. Armor protected the crew. A power turret armed with a .50 caliber machine gun provided defensive firepower. The aircraft carried radar for night and bad weather operations. Most critically, American industry produced over 9,800 Avengers compared to Japan's total Kate production of 1,149. The quantitative gap matched the qualitative one. The production numbers tell the industrial story. Nakajima manufactured 669 B5N1S and B5N2S at their Koizumi plant between 1936 and 1941. Ichitoke Denki built an additional 200 B5N2S between 1941 and 1943. The Daijuichi Kaigun Kokusho, 11th Naval Air Arsenal, produced 280 more B5N2S through 1943. Total production reached 1,149 aircraft over 7 years. By comparison, Grumman and General Motors built 9,839 TBM Avengers in 3 years. The quantitative disparity reflected fundamental differences in industrial capacity. Japanese aircraft production prioritized fighters over bombers as the war progressed. Zero production reached approximately 10,000 units. The Navy needed fighters desperately to contest American air superiority. Every production slot allocated to torpedo bombers meant one fewer fighter. The choice became obvious: build aircraft that could defend rather than aircraft that could attack. By late 1943, offensive carrier operations had largely ceased. Japanese carriers, when they operated at all, served primarily as fighter platforms defending against American strikes. The Kate's offensive capabilities became irrelevant in this defensive context. Engine production created additional constraints. The Nakajima Seiki radial that powered the B5N2 also powered the A6M0. Mitsubishi required these engines for Zero production. Nakajima needed them for their own Zero production under license. The competition for available engines meant bomber programs received lower priority. The B6N Tenzan, designed to replace the Kate, used a different Nakajima Mamoru engine that suffered chronic reliability problems. Many B6NS sat grounded awaiting engine repairs or replacements. Commanders preferred reliable B5NS with proven engines over superior B6NS that might fail mid-mission. The pilot training pipeline collapsed under attrition that couldn't be replaced. Pre-war, Japan trained approximately 100 naval aviators annually through a selection process that accepted perhaps 5% of applicants. These pilots underwent 3 years of training before reaching operational squadrons. By 1943, the Navy needed to replace hundreds of pilots lost in combat. The training pipeline expanded: more students, faster courses, lower standards. By 1944, pilots reached operational squadrons with 6 months of training. By 1945, some kamikaze pilots had only weeks of instruction. They could take off and fly straight. They couldn't navigate precisely, couldn't coordinate with other aircraft, couldn't execute complex tactics. In their hands, the Kate's sophistication became wasted potential. The Kate's extended service thus becomes comprehensible as a symptom of Japan's strategic dilemma. They couldn't replace it because replacement required industrial capacity they didn't possess. They couldn't retire it because they needed every aircraft for the desperate defensive campaigns of 1943 to 1945. They couldn't significantly upgrade it because the basic design had reached its limits. Adding armor would reduce speed, enlarging the engine would require redesigning the airframe, improving armament would add weight. The aircraft existed in a technological dead end, unable to evolve further without ceasing to be recognizable as the Type 97. From the perspective of 1945, looking back at Pearl Harbor, the Type 97 illustrated both Japanese genius and Japanese tragedy. The genius, recognizing before any other nation that coordinated carrier strikes could achieve decisive results. Building an aircraft specifically optimized for that mission. Training crews to execute the mission with near-perfect precision. The tragedy, succeeding too well in early battles, creating expectations that later reality couldn't meet. Failing to develop adequate replacements before obsolescence crippled the original weapon. Fighting a war of attrition with specialized weapons designed for decisive battles. The Kate was the right aircraft for the wrong war. The legacy extends beyond simple technical assessment. The Type 97 forced American naval doctrine to evolve. The devastation at Pearl Harbor drove reforms in damage control, anti-aircraft systems, and fighter direction. American carriers learned to launch coordinated strikes, imitating Japanese methods. The proximity-fused shell, developed partially in response to kamikaze attacks, revolutionized anti-aircraft warfare. The emphasis on radar and night operations, areas where Americans held advantages, stemmed from Japanese daylight strike successes. In this sense, the Kate shaped American victory even as it flew toward defeat. The human dimension matters most. Thousands of young Japanese men climbed into Kate cockpits knowing their aircraft was obsolete, their mission likely suicidal, their prospects nil. Some, in late 1944 and 1945, flew kamikaze missions with only rudimentary flight training. Others, veterans of early battles, continued flying combat missions out of duty or desperation. The courage involved, flying an unarmored, lightly armed, slow aircraft toward targets defended by radar, fighters, and massive firepower, deserves recognition separate from the politics and morality of the war itself. These men did their duty as they understood it, operating equipment that by 1945 standards was suicidally inadequate. The technical specifications, when viewed in this context, become more than numbers. Maximum speed of 235 miles per hour meant flying toward targets while knowing faster enemy fighters would intercept. Service ceiling of 27,100 feet meant operating below enemy fighters' optimal altitude. Range of 1,200 miles meant flying hours toward targets with hours of return flight afterward, if the aircraft and crew survived. The single 7.7mm machine gun represented a gesture toward self-defense rather than meaningful protection. Carrying 800 kilograms of torpedo or bombs meant flying a heavy, unresponsive aircraft that couldn't maneuver violently. Every specification translated into a human experience, fear, determination, and often death. The Type 97's operational history from 1937 to 1945 spans an era in aviation technology. In 1937, when it entered service, the Kate represented modernity, monoplane design, retractable gear, all-metal construction. By 1945, such features were baseline assumptions. Jets were flying. Radar-equipped night fighters prowled the skies. Guided missiles represented the future. The Kate belonged to an age already receding into history. That 8-year span contained more technological change than the previous 30. Aircraft that seemed advanced in 1941 became antiques by 1944. The Type 97 suffered this obsolescence more visibly than most because it continued flying frontline missions long after retirement age. The doctrine that supported it became equally obsolete. The massive coordinated carrier strike, the tactic that devastated Pearl Harbor, proved impossible to sustain after 1942. American combat air patrols broke up formations before they could coordinate attacks. Radar warning gave defenders time to prepare. Fighter direction concentrated interceptors at optimal positions. The beautiful precision of first-wave Pearl Harbor, with torpedoes, dive bombs, and level bombers all arriving simultaneously from different vectors, never recurred. Later battles saw piecemeal attacks, desperate individual efforts, kamikaze chaos. The Kate, designed for coordinated precision strikes, ended its service flying alone into defensive fire. The irony deepens when considering that Japan possessed the knowledge to build better torpedo bombers but lacked the industrial capacity to produce them in necessary quantities. The B-6N Tenzan that was meant to replace the Kate flew its first combat mission in August 1943, almost 2 years after Pearl Harbor. Even then, chronic engine problems limited its effectiveness. The Mamoru engine overheated in tropical conditions, suffered from inadequate cooling, and proved mechanically unreliable. Many B-6NS sat grounded awaiting replacement engines that never arrived. Production totaled only 1,268 aircraft over 2 years, barely exceeding the Kate's 7-year production run. Commanders often preferred keeping their reliable Kates over accepting temperamental B-6NS that might fail at critical moments. The doctrinal legacy extended beyond the war itself. American naval aviation absorbed lessons from Japanese carrier strikes and implemented them in post-war carrier operations. The concept of coordinated multi-carrier strikes became standard doctrine. The emphasis on intensive crew training, though initially dismissed as unnecessary perfectionism, proved its value. American carrier tactics in Korea, Vietnam, and later conflicts bore the fingerprints of Japanese innovation, integrated strikes, multiple attack vectors, sophisticated coordination. The torpedo itself saw continued development based on Type 91 principles. Post-war American and Soviet torpedoes incorporated stabilization systems similar to those pioneered by Japanese engineers. The ability to drop torpedoes from high-speed aircraft at low altitude, once uniquely Japanese, became standard capability worldwide. Modern anti-ship missiles follow attack profiles developed by Kate crews, low-altitude approach to minimize radar detection, multiple simultaneous impacts from different vectors to saturate defenses, precise targeting of vulnerable areas below the waterline. The human cost defies precise calculation. Of the approximately 3,500 Japanese naval aviators who began the war in December 1941, fewer than 100 survived to see August 1945. The rest died in combat, training accidents, or kamikaze attacks. Many Kate crews perished in the aircraft that served them so well at Pearl Harbor, Coral Sea, and Santa Cruz. Juzo Mori survived the war, one of the few Kate pilots to do so. His memoir, published decades later, describes the psychological toll of flying obsolete aircraft into modern defenses. He writes of watching friends die in aircraft identical to his own, understanding that his survival was luck rather than skill. He describes the guilt of survival. Why did he return when better pilots died? The technical specifications, viewed from the perspective of 1945, read like epitaph. Maximum speed 235 miles per hour, insufficient. Service ceiling 27,100 feet, inadequate. Range 1,237 miles, impressive but irrelevant. Defensive armament 1 7.7 mm machine gun, laughable. Armor protection none, suicidal. Yet these same specifications had enabled stunning victories in 1941 and early 1942. The aircraft hadn't changed. The war had. The final assessment must separate the weapon from its employment. The Type 97 Kate was not a bad aircraft. Within its design parameters, a specialized torpedo bomber optimized for coordinated carrier strikes, it excelled. Its long service life reflected not its continued effectiveness but rather Japan's inability to replace it with anything better. The tragedy lay not in the aircraft but in the strategic context that kept it flying long after obsolescence should have forced retirement. Modern military aviation teaches the Kate's lessons repeatedly. Specialization creates vulnerability. Superior training provides temporary advantage but cannot survive sustained attrition. Industrial capacity matters more than individual platform quality in extended conflicts. Coordination multiplies effectiveness but requires experienced crews to execute. These principles, written in the wreckage of Kate scattered across the Pacific, continue informing military planning today. The 2 surviving Kate fragments, one in Britain, one in Hawaii, serve as physical monuments to an aircraft that changed naval warfare. Visitors to the Pacific Aviation Museum in Pearl Harbor can view the reconstructed Kate displayed near the hangar damaged on December 7, 1941. The aircraft sits in the same harbor it attacked, a silent testament to the men who flew it, the ships they sank, and the war that consumed them all. The placard describes specifications and history. It doesn't mention that the young men who climbed into such cockpits knew they flew outdated aircraft against overwhelming opposition. It doesn't need to. The aircraft itself, fragile-looking and antiquated, tells that story eloquently. The paradox remains, how did an outdated aircraft remain deadly throughout the entire war? The answer lies in understanding that deadly has two meanings. The Kate remained capable of sinking ships, the torpedo it carried and the physics of underwater explosions never changed. But the probability of delivering that torpedo decreased catastrophically as American defenses improved and Japanese training deteriorated. By 1945, the Kate was deadly primarily to its own crews, flying missions that had become exercises in futility. Yet some missions succeeded. Some torpedoes found targets. Some ships sank. The Type 97 remained dangerous not despite its obsolescence but because naval warfare's fundamental equations, put explosive below waterline, ship sinks, transcended technology. If the Type 97 Kate has given you a new way to see the Pacific War, like, share, and subscribe, and tell us which moment surprised you most. We'll return next week with another chapter in the war that changed the world.